is look at our addition table. Look at our addition table, for example, like mod. What mod is this? Mod 5. You can pick any one you want. Then we have our addition table, which is a very easy shift of the rows. And you can assign to each number a little graphical, something that's nice graphically. Now there is some structure. If you look at the additive, you pick 0, just empty, just all one color. Then you pick something like this for 1, and something like that for 2, something different. And you can experiment with different things. The additive inverses get the same configuration, but the colors are flipped. So the additive inverse of 1, mod 5, is 4. So you see how they're very similar, but red is black and black is red. Same for these two. They're additive inverses. That would give you a nice diagram in the end. So then wherever you see these numbers, they appear, they get replaced by these 5 bigger squares, and you get what we call mod art. You get that nice pattern coming from the underlying mathematical structure. Now you can of course attach many of these, 3 more of these together to create something that looks pretty nice. You just no, it doesn't. Then you can of course go and say, let's do something similar, but stretch it out a little bit, or compress the bottom right corner a little bit. And if you put those together, you get an even nicer effect. So you can create a lot of different, not illusions, but sort of nice art using this underlying simple arithmetic. This one, I can't quite see where the underlying table, how the underlying table was distorted and what the actual pieces are, but it makes it even more artistic. So, I forgot to hand these out. Probably more than 3, right? Take one hand back. It's done for you in the book, I know, but turn this up and just rotate this back. So an exercise that one can do, oops, now log out, no, subconsciously, is this is one example of something that you could do to create your own mod 4 part in this case. So you take the very simple case. Mod 3 is a little too small, so 4 is a nice starting point, and you fill in the addition table, which we have 9 minutes to do. We can do it. So let's fill in the addition table, and then distort it by sort of squishing the 2 top corners together. So those addition tables should not, especially because it's addition, the table should take you like 5 seconds. Because you're just shifting the rows, there's very little thinking involved. And I think this is discussed in the book as well, but it's sort of done for you. Yeah, towards the end. And I can't afford color printing, so it doesn't necessarily look as good, so I wanted to show it. So you fill that in, and then you copy it over with your distorted table, and you can distort that in many ways, right? This is just one example. Fill in all those numbers. Then now you have to sort of decide on a color combination. One way to make the individual squares more interesting is to split them up into 2 colors, and then we can decide on the colors. The key that makes the mod art visually appealing is that the additive inverses are flipped in color. Additive inverses should have the same basic design, well, they all have the same in this case, but see how 0 and 3, the colors are just flipped. Whatever colors you choose, the additive inverses have to be just the, I'll call them the flipped versions, just like 1 and 2 are. Otherwise, your mod art would still be fine, and it just wouldn't have that symmetry and that nice pattern. It's really the additive inverses that give that. So you can pick colors or shadings or do whatever. I'll leave it up to you. You don't have to do it. I'm just running you through it because in the book it's all black and white, so it doesn't show that well. So one thing you could do, I have done it there. Keep going. We can pick some basic colors. Then color the 0, 1, 2, and 3 squares accordingly. So that doesn't necessarily show in the book. A little bit, not really. A and C look pretty similar there, but in fact it's red and blue. Make it even more appealing. Not that the black and white version is bad, still pretty good. And then you put those in place of your distorted table, and you get, where is it? Something like that, which looks nice on its own, but when you make a full circle, it looks even better. And the patterns and the symmetry that you're seeing is because of the additive inverse having the same configuration but the opposite color scheme.